Let's look at the properties of wind and how wind is generated. It's important to know the properties of wind and the distribution of wind in a certain location in order to properly calculate the power density of a wind turbine, which is not as simple as just adding velocity V. Let's look at this picture of the Earth. And what we need to remember is that wind is created because of distributing heat. So uneven heating of the Earth is what creates the wind. At the equator, I'm going to sort of redraw this so we can go through it together. At the equator, it's hotter, right? This is the equator. It's hot here. It's hot at the equator, so the heat rises at the equator. And then as the heat rises, it then it travels about 10 to 15 kilometers above the surface. So it rises and then it falls again. It rises and it falls. It rises and it falls about 10 to 15 kilometers above the surface. So this is what creates wind. So basically the heat is rising from the equator and it's falling in the colder regions, and then it's transferring back to the warmer regions. And that's, in effect, if you were to summarize in one sentence, what causes wind? It's the movement of heat, because the Earth is hotter in different places. So if we look at 30 degrees above and below the equator, and we look at 60 degrees latitude above and below the equator, then what happens actually is the effect of the heat is traveling in opposite directions. So here the heat comes up, back, and down, but where it is colder in this region between 30 and 60, it actually flows the other way. So if I were to draw the arrow, it would be this way. And again, here, I would draw it coming up, and in this region, I would draw it going down. And so there's an opposite effect in each region. And what that ends up doing is it's making this closed circulation or convection that goes in opposite direction. And that's what's called trade winds. So because of this, you get trade winds going in this direction here, and then they go in this direction here, and they go in this direction here. This direction, and this direction again. So those are your trade winds. Which I don't really need you to know about, but it's really interesting. This is our North Pole and this is our South Pole. And then there's another name for these winds at the North and South Pole. At the North, they're called, North and South, they're called polar easterlies. Oh dear. All right, so at the North and South Pole, the winds are called polar easterlies. Easterlies means it's heading in that east direction, whereas these are called westerlies. And down here again, you have another polar easterly in this region here. And that's shown on this diagram also that I pulled from the internet. So those are your trade winds. You also have some surface winds. So surface winds, we can talk a little bit about them. You have surface winds, and sorry, these easterlies are called trades. They're easterly trade here and here. So sometimes you hear in the weather forecasts about trade winds. So that's what you see there. Then you have some other, those are actually all surface winds. You also have some local effects. So these surface winds are due to heat. But then you have some local wind effects, which are worth talking about. You have like lake effect or body of water effect, where the water is going to hold its heat more than the land. So the land is going to cool and the water has not, or vice versa, depending on the season. And that means heat transfer. So say from a water body like a lake, that you hear lake effect winds, right? So that's because of the heat transfer from water to the land that has cooled down. And then you also have orography, so the effect of elevation is going to cause that wind to be accelerating or decelerating around changes in elevation. And then you have roughness. And roughness on land is going to make friction, which is going to slow down the velocity. So that's just, and you don't really need to know this, but it's just interesting. This is sort of where wind comes from. In a quick video to just kind of position ourselves before we learn about wind distribution, to know a little bit about sort of the common sense background of why we have the wind that we have.